I'm Charlotte O'Brien, and I'll be talking to you about the Hurricane Katrina tornado outbreak. So the outbreak is considered to be the normal sibling because it has characteristics typical of an average tornado outbreak compared to the abnormal characteristics of Hurricane Katrina. So the tornado outbreak happened from August 28th to the 30th in 2005. It touched down starting in the Gulf and affected most of southeastern U.S. So in this picture, it shows a portion of the tornado outbreak. And as you can see, each tornado is named after the town that it touched down in. So the Hurricane Katrina tornado outbreak path left a curved northeastern path across southern U.S. As shown by the red marks in the region. In total, there were 59 tornadoes that left a lot of damage to the south region of the U.S. So each wind or each tornado is categorized on the Fujita scale by how fast their rotational wind speed is. The aftermath of a tornado can also represent where that tornado landed on the scale. As you can see in the picture, it shows very little damage because because an F2 tornado touched down there, causing moderate amount of damage. So each hurricane produces at least one small or weak tornado, typical of that kind of nature. In total, Hurricane Katrina Hurricane Katrina had about 30 F0s, 23 F1s, and 6 F2 tornadoes. Mainly the 6 F2 tornadoes touched down mostly in Georgia, as that was the most deadly and catastrophic state. Okay, so where can we find these tornadoes? You can find these tornadoes. They mostly occur on the outer bands of the hurricane, in the front right quadrant due to the hurricane's spin. So this is a picture of Hurricane Katrina first making landfall. And as you can see, the outer bands are where they first touch down on land. And because they're the first part of the hurricane to touch down on land, they're the first to decay. But fortunately, as they start to decay, that means that prime conditions are able to develop tornadoes. So how does it form? So there are two main components in a tropical cyclone tornado's formation. Number one is vertical wind shear. So as the Hurricane Katrina made landfall, the low altitude winds really came in contact with the surface, and there was a lot of friction that slowed down the winds, while the higher altitude winds really sustained their intensity, and there is a lot of difference between them. So that difference, combined with the new directions that the winds constantly take, creates a very strong vertical wind shear. Number two is thermal instability. So thermal instability is really important because it allows for an area of convection to happen within their supercell cloud. So convection helps to produce convective clouds like cumulonimbus, but since thermal instability is found lower in altitude in tropical cyclone tornadoes, then they aren't able to really reach their max height and become a very big and strong tornado, typical of a mid-latitude tornado. So when they stop growing, that's because they reach a pocket of stable air that prevents them from growing anymore. So that's called a temperature inversion, and those temperature inversions are normally why tropical cyclone tornadoes are often more weak and smaller. So these three pictures are of the same county in Georgia where an F2 tornado touched down in. They basically just highlight the biggest extent of damage that the tornado outbreak from Katrina had. It was mostly the hurricane itself that caused the majority of the destruction. Okay, I'm Charlotte O'Brien. Thank you for watching.